Science time! Welcome to the DIY Science Zone. First, Tori Stenmark starts off with some explosions by demonstrating the combustion of hydrogen in an Orange Community College classroom. During the experiment, she's wearing a face mask and a clear face shield and a rad jacket. Safety first. Then, Lolly DeRossier will take over from her well-used office to show us how to collect DNA from a strawberry. Finally, our very own Dr. Ray comes at us from the comfort of her kitchen in cozy sweats to do some colorful, flower-powerful chemistry. Take it away, Tori.
Hi there. My name is Tori Stenmark. I am the DIY Science Zone Assistant for Geek Girl Con, and I'm also Associate Faculty at Shoreline Community College. The demonstration you're about to watch was filmed on the Shoreline campus in accordance with all of their COVID-19 protocols. So I wanted to say hi and show you my entire face, and I also wanted to give you a heads up. The experiment you're about to see includes both loud noises and flashes of light. So if that's not your thing, feel free to mute the audio, look away from the video, or just skip to the next segment, whatever you want to do. This particular experiment is one that I've wanted to do, or something like this, for a very long time, pretty much ever since I've been working with Geek Girl Con. But it turns out that convention venues get kind of upset when you blow things up and set things on fire in their facilities. But Shoreline Community College was gracious enough to let me use their resources and film on their campus. So that's what I did. And please enjoy the combustion of hydrogen. Hi there, I am Tori Stenmark with Shoreline Community College here for Geek Girl Con. And today at our DIY Science Zone, we're going to do some explosions. My favorite. So what I have here are some balloons filled with hydrogen gas. And I'm going to react that hydrogen with oxygen. Let's see here. Two molecules of hydrogen gas plus one molecule of oxygen gas are going to give us 2 molecules of water. Might be gas phase, might be liquid. We might actually see some liquid water coming out of this. But the really fun part is that as this reaction happens, a whole bunch of energy gets released in the form of heat and light. And boom. Technical term. So we're going to begin over here on the far left, and you can see this balloon is kind of floating up a little bit because hydrogen is less dense than air. All right, time for explosions. Now I brought several hydrogen balloons here because I wanted to also talk a little bit about the impact of chemical reactions and color here. So in the rest of these balloons, I have a few different metal salts that, when they burn, are going to become give off light in different colors. So we get that nice kind of orangish flame with just the hydrogen. But as soon as we start introducing metal salts, they give off colors as they burn. This is the chemistry of fireworks here. It's the exact same thing that happens when you see a firework go off for 4th of July or whatever holiday. Fire. All right, so first off, we had plain hydrogen. Next one, I am pretty sure, is strontium. That red color you get is that strontium metal going up. And this one here should be copper 2 chloride. Copper can be blue or green depending on the ionization state that it's in. That one was green. And lastly, this should be a different shade of green. That one is barium. So that's a little bit of explosions for you, a little bit of demonstration of the chemistry of fire and that reaction. Now you can't really tell here, but there's definitely a little bit of residue on the whiteboards, which is probably a little bit of that water that's being produced. But of course the exciting part is that heat and flame and light that we get off in those explosions. So that is our demonstration for today. Thank you for watching.
Hi everybody, I'm Lolly DeRosier. I'm a biology teacher, and today I'm going to show you how to extract the DNA from a strawberry. But first you're going to have to gather a few things from around your house. First, you're going to need a strawberry. You only need one. You're going to need a small plastic cup, an ordinary coffee filter, a small zip-top bag, some ordinary table salt, just a pinch or two, a few drops of clear liquid soap, and some isopropyl rubbing alcohol. I'm using 70% rubbing alcohol. There are other percentages that work just as easily. And it's also best if the rubbing alcohol is just a little bit cold. Now this strawberry has millions of cells, and inside each of those cells is a tiny molecule called DNA that is very thin, just 2 nanometers wide, and also extremely long. If I took the DNA out of a single human cell and stretched it out as far as I could, it would reach about 2 meters in length. But in order to get to the DNA inside these cells, it's got to go through a few physical changes and a few chemical changes. So here's what we're going to do. First, you're going to take your strawberry and you're going to put it inside your Ziploc bag. Try to get all the air out of the Ziploc bag as much as you can, because when we start to squish the strawberry, we don't want the Ziploc bag to pop. Your next job is just to start squishing. Now notice I said squish and not smash. If you take the bag and smash it, you're going to pop it and then you'll wind up with strawberry all over your clothes. So by the time you're done, it should be about the consistency of a strawberry smoothie. So squish, squish, squish. The more you squish, the better your results are going to be. I'm going to pause my recording and keep squishing my strawberry. You keep squishing too, and we'll meet back here in a couple of minutes. All right, how did you do? My strawberry is all liquidy, not a lot of large lumps, and we're ready to move on to the next step. I'm going to move as much of that strawberry down to the bottom, and we're going to add some ingredients into this bag that's going to now help to break apart the individual cells of the strawberry, the individual little compartments that each has its own strand of DNA. Because this strawberry has millions and millions of cells, and each cell has millions and millions of little molecules of DNA inside, we're going to get a lot of DNA from this strawberry. We're going to carefully open our bag, and I'm going to pour in just a little bit of water. It can be any kind of water. I've got some here in my drinking tumbler. I'm putting in about a 1/4 cup of water. I'm going to add to that 3 or 4 drops of my soap solution. And then I'm going to add to that just a pinch of salt. Just about that much salt is all you need. Maybe 1/8 of a teaspoon if you really like to measure it. I'm going to seal up the bag again, being very careful because we're going to mix a lot of fluid here. And I want to mix it, and I want to make sure that everything mixes together. I see that some of my soap got stuck to the side of the bag. So I'm going to mix it very gently. And I'm going to try to mix it so that I don't get a lot of suds. We're going to get some, but you want to try to keep that to a minimum. I'm probably going to mix that together for maybe 30 seconds to a minute, making sure that it gets all throughout the strawberry solution. All right, that looks pretty well mixed. I'm going to double check to see that it's sealed. And I'm going to set that baggie aside for just a second because now we're going to set up our filter. I'm going to take a small plastic cup. This one looks to be about an 8 to 10 ounce plastic cup. I'm going to take my coffee filter and I'm going to push the coffee filter down about 2 to 3 inches into the cup. Looks like about 2 inches. And I'm leaving about a 1-inch edge of coffee filter over the top because I'm going to take that edge and I'm going to fold it over and I'm going to secure the edge with a rubber band around the top of the cup. So now what I've effectively got is I've made a little bowl in the top of the cup using the coffee filter. There's enough room for me to pour fluid inside. So you want to make sure that there's a little bowl there. It's being held on by the rubber band. I'm going to take my strawberry solution that I've mixed with the soap and the water and the salt, and I'm going to very carefully pour that into the cup. You might want to have somebody help you with this step, maybe somebody to hold the cup while you pour so that it doesn't get knocked over. I'm going to pour all of the strawberry solution, or as much of it as will fit, into my filter, being very careful not to make a mess. Now remember, all of the things that we're using in this activity are ordinary household items. So if you get them on your hands, it's not going to hurt you. In fact, you'll probably smell like strawberries. You just want to be very careful not to get it in your eyes. So as we sit here, the strawberry solution is filtering down through the coffee filter. All of the pieces of strawberry are left in the top, and all we're getting into the bottom is the water, and it is carrying with it the fluid that was inside the cells, hopefully also containing the DNA. Let me show you what it looks like from the side. So here's my filter, and this is all of the filtered fluid from the strawberries, and it's draining out of the top. So this is more than enough for what we need to do. Even if you get a lot less fluid, even if you only get about half a centimeter, that's plenty for the test that we need to do. This next part's a little bit tricky. We need to get this filter off without accidentally spilling any of the pieces of strawberry into our clear solution in the bottom. So what I'm going to do is I'm going to pull my waste basket right over here next to me, and I'm going to hold with 2 fingers. I'm going to hold the edge of the coffee filter, and I am going to pull the rubber band off. I'm going to pull it straight up, and then over the trash can, I'm going to gather up the edges of the coffee filter like it's a little bag and just move it directly into the trash can with all of the strawberry pieces inside. There we go. And what I'm left with is my strawberry, what we call my strawberry filtrate in the bottom of this cup. Now, this next step is the addition of the alcohol. The alcohol is what's going to bring the DNA out of this solution, and it's going to let you actually see the DNA and touch the DNA. You can do this step directly in this cup. You don't have to transfer it. But because I'm on camera and I want to make it a little easier to see, I'm going to transfer it to a glass vial. If you have a vial at home, you can do this. If you have a test tube, you can do this. If you even have like a skinny small glass, a drinking glass, that'll work also if you wanted to do it in a separate cup. So here we are. I've transferred the strawberry filtrate to this glass vial, and I've only poured in about a third of the vial. To this, I'm going to very carefully add my rubbing alcohol. And I'm going to add about the same amount of rubbing alcohol as I have strawberry filtrate. What you want to do is you want to look right in the space where the rubbing alcohol and the strawberry filtrate meet each other. That's where you will see the DNA starting to form out of the solution. It will look like a wispy white cloud. When you pour the alcohol in, you want to just leave the solution very still. Give it about a minute to work. You don't really want to swirl it around or stir it with a spoon or anything or agitate it in any way. Just leave it very still. So here we go. I'm going to carefully pour my alcohol solution kind of down the side of the glass. And you can see that the alcohol kind of stays on top. That's because the alcohol is less dense. And there it is. You can see the DNA starting to form in that solution. That wispy white cloud of bubbles right in between the strawberry layer and the alcohol layer is the DNA. Right there. That represents billions and billions of nucleotides or building blocks of DNA. And as I let it sit here, it will get thicker and thicker and thicker. Now, if you want to touch the DNA, you can reach in there and pull it out. I've got a popsicle stick. This is kind of big for what we want to do, but I'll give it a try. I kind of can slide it out, and you can see it's kind of goopy. There it is. You can see it in the solution. There's the DNA. You can use a coffee stirrer. You can use a bamboo skewer. You can use a really long toothpick, and you can try to fish that out. When you touch it, it will actually be really hard for you to feel it with your fingers because the molecule is so light. So experiment with that, play with that. As always, when you clean up responsibly. You can just, because this is just rubbing alcohol, soap, water, and salt, you can put it right down the sink. Just make sure to run the water. Don't splash any in your eyes. Try it with other fruits. Try it with grapes. Try it with kiwis. Try it with bananas and see how much DNA you get. Have fun. Good luck. And you can find me on Twitter.
Hello, I'm in my kitchen and I am ready to do some really fun chemistry. So here's some roses. They've been in my house actually for a couple of weeks. And so I thought, hey, it's time to do some fun with roses. Now, first thing we're going to want to do is make a rose tea, which is actually super easy. So I'm going to take one of the roses and I'm just going to take all the petals. Be careful if your rose has thorns. You really want to use a dark pink, a red, a purple, something that's really got vibrant dark colors. And I'm just going to put all the petals I can and drop them into a Pyrex, mine's a measuring cup or a coffee cup. Something that can take hot water because again, we're going to make a tea. So I'm going to put this aside. I already had some hot water going from my kettle. Going to add in maybe a cup, about a cup. And I've got a nice spoon out. So gonna let that steep. So here's what it looks like. Just rose petals and water, right? And the first step is just to let that sit for 5 to 10 minutes. So because I don't want to bore you, I'm going to actually let that work its magic and then we'll come back and do some more cool stuff. So while we're waiting for the roses to do their thing and steep, we've got a few more minutes, just want to let you know a little bit about the chemistry. So the color of roses is really due to a class of compounds called anthocyanins, and they're a whole class of compounds. And it turns out that these pink and red and purplish ones have an anthocyan that's a similar structure, and they are what are called acid-base indicators because they themselves have an acid form, a neutral form, and a basic form. And really it comes down to the removal or the addition of a proton, what we call a proton, but really that's chemistry shorthand for hydronium or a H plus ion, depending on the whole reaction scheme that we're talking about. And you might be like, what is she babbling about? But basically it comes down to the addition or the removal of an H plus. And so that's kind of the most general basic definition. Now, when an acid comes in contact with a base, this reaction can occur. This potentially removal or addition of that H, depending on, are you looking at the acid, which would be kicking off an H to the base, and the base would be accepting it. Then notice that both the acid and the base in that context, the acid losing an H and the base gaining that H, their structure has changed. Now it might just change a little bit, just that H, but that could actually lead to big color changes because the structure has changed. Or that initial change could kick off a series of other structural changes that are a little bit more significant. And if you have a different structure, you could potentially have a different color depending now on the different types of light that you absorb versus the ones that you transmit that get to our eye. So the cool thing about roses is that these molecules, these anthocyanins, they're responsive to their environment, right? So what it can tell you, this type of tea, is that, hey, am I in the presence of an acid or am I in the presence of a base? So if I'm an anthocyan like the ones that are in roses, and particularly this type of rose, these colors, if it's an acid, I might stay in the pinks and maybe even get a little bit more pink, or what my eye would perceive as pink, which would actually be red of a certain intensity, certain saturation. And so if it's acid, I might get more in that realm. However, as I start moving, if I'm in the contact of a base and I'm an anthocyan, then that means that a completely different reaction is going to occur because I'm in a different environment and I'm going to become greenish, bluish. And that's a really different color because now the light that structure, that compound is absorbing and the light it's transmitting to our eye is completely different on opposite ends almost of the visible range, that light we can see, the ones that we actually go, ooh, pretty color, red, green, blue, yellow, orange, right? Those are at opposite ends of the spectrum. So again, even those small changes of just an H, right, taking or giving away can make these big color changes between, say, reddish and blue, right? And so that is really cool. So that's why it indicates that it's in a different environment. And that's really useful because we can then use a solution like this, a pH indicator, to investigate what's going on in some other solution or what some other chemical is. Whether something is an acid or a base really tells us a lot about potentially its structure, its function, potentially if we need to be cautious about it from kind of a health and safety standpoint. So having a pH indicator can really tell us a lot of information. And so by using a solution like this, we can investigate, hey, is lemon juice an acid or a base? Is vinegar an acid or a base? Are these a little bit different from each other even though they're both acids? Or are they similar? What about baking powder versus baking soda? Now, if we expose all of these to this solution, we could learn a lot, and that's what we're going to do in this video. All right, so we're back, and the tea is done, and I've put just a little bit into each of these glasses. Now, you'll notice I've got, it's actually white paper towel and kind of a little bit of a white paper towel tint, and that's because it'll help us see any kind of color changes a bit easier. Instead of using the darker background of my kitchen counter. So I might actually put a little bit more in each one. And you'll be surprised, the color is actually kind of a brownish color, right? Rather than the appearance it is in the roses. And so I'm just putting about another 25 milliliters. So each of these glasses now has about 50 milliliters in each one. So have it there. And so maybe see if you see how that color is? It's kind of a really, really light brown, it looks to me. So what we're gonna do is I'm gonna add lemon juice to this one, and then we'll see how it looks. Okay, so this is just lemon juice from the store, but if you have fresh lemons, super, use that. So how much to add? Well, first I'm totally not gonna do this quantitatively. I'm gonna just pour a little bit into the cap. Try not to make too big of a mess, but it's okay if we make a little bit of a mess. And so I'm gonna put the lemon juice in here. Okay. And I see a big color change. Look how it's gotten more pink. And so I'm gonna actually mix it together. Okay. And it actually looks, may not pick up a little bit on camera, but it actually looks a lot more pink than it did before. So this is what it looked like before on this side that I'm moving around. And this is what it looks like after the lemon juice. And if you put them down, this one looks more pink. So from the solution we made with the roses, then that kind of implies that if more pink means more acidic, then I've just made the rose solution more acidic, which makes sense because I've added lemon juice, which is acidic, pretty acidic. And so that's pretty good. That fits with what we know about lemon juice. So that's always makes me feel good when that works out. So another thing to add, okay, so let me fix my paper towel tint, is we'll do another acid. This one is white vinegar, which again should also be an acid, just from what we know, but let's check it out. So I'm gonna again put just a little bit in the cup. And one thing to think about too is with the lemon juice, it actually isn't colorless, and so that's gonna influence. And it had a little bit of like particulate matter from the lemons, so that's why it's probably a bit cloudy, but it's definitely got a pinker tone. But you're going to want to investigate this for yourself by making your own rose solution. All right, so I'm going to add the vinegar into this one here. Okay. Same kind of thing. In fact, pink, but not nearly as cloudy because the solution itself is, quote, crystal clear and colorless. And that's not the case with this lemon juice. Okay. So here's, let me see how it actually looks a little bit more pink. I'm going to hold this up for you. There. Okay. And if I do that, and then here's one that's just the rose tea that we made, you can see there's quite a color difference, and this one's got more red. To our eye it looks a bit pink, or to my eye it looks a bit pink, and so that fits again. So that means that our rose our anthrocyan is in an acidic environment, which made it pink. Okay? Now, what are we expecting from something like baking powder, baking soda? Right? So if we look at, it's my old container from my baking cabinet. If we look at this, it's got sodium bicarbonate, and that is a really fun compound because it can act like an acid or a base depending on what it's interacting with. So I've just got a 1/4 teaspoon. I'm not going to put that much in. I'm just using it as a little receptacle. I'm going to try putting in a lot less than that powder. So I'm going to add it to this third one. I'll pull it forward a little bit. Put it in there. See what happens. Bit cloudy, kind of looks the same color. A bit yellow, kind of got a bit more yellow. Let me see what happens if I add in a bit more. Adding in a bit more. Yeah, definitely like a yellowish color. It's cloudy, very similar to when we added in the lemon juice. Since this is going to be the only one I do with this one here, we'll go ahead and kind of use it as a mixing one. So definitely not a whole lot of change, if I may say. So this cloudy one is the one where I added the baking powder, which is sodium bicarbonate, and our rose tea is this one that I'm tapping with my finger. So, it definitely, I can say based on what we saw with the two acids that got distinctly more pink, that this sodium bicarb didn't go in the pink direction. So it's definitely, the anthrocyan isn't in a more acidic environment. It doesn't look like it's in much of a different environment. It got, maybe it got yellow or it just got cloudy, but I'm not seeing that big color change I saw with these two acids. So not a big change there. So maybe it's very similar to the rose anthrocyan. Not a big difference, not a big shock to the rose anthrocyan. So let's try our last one, which is going to be baking soda. And baking soda is also sodium bicarbonate, but it doesn't have some of the other ingredients that this one has, such as cornstarch. This one has baking powder, has cornstarch, sodium bicarbonate, sodium aluminum sulfate, monocalcium phosphate. So it's got some other fun stuff. And this one, however, just has your sodium bicarbonate. So I'm going to use another small 1/4 teaspoon and see if that makes a difference, if maybe those other ingredients made some type of a difference. So let's see. Ooh, I got a whole lot out. Hopefully I won't put in that much. So it too is yellow. It's distinctly yellow, not nearly as cloudy. It's almost a yellowish green, and that kind of tells me it's going towards the base side, because when you get your greens and your blues for this particular anthrocyan, you're going more towards the bases. So that's what that tells me. I'm going to dump out the extra down my sink. Stir this up a bit. But I will say, because it didn't have baking soda, does not have all those other ingredients, that it's a lot more clear than the baking powder. So the cloudy one is the one to my right is the baking powder, and the one here that I'm tapping is the baking soda. Both of them look kind of yellow, on that tone, and this one definitely, to me, when I'm looking at it, the one to the left has a slight bit of kind of pale greenish to the yellow, which again, going towards yellow, green, blue means that you're getting more basic. Alkaline is another thing. I don't want to call someone basic. That's not very nice. And so that's one thing that we can think about. Okay, now, what are we going to do now? Well, this is the fun part. You could literally go investigate all sorts of stuff in your house and just see, what is it going to give you? So I'm going to go get some more stuff and get a new array of stuff and see what we find. All right, I'm back with more things to investigate. And this is what you can do at home. You make your rose tea, and then you do a setup similar to this, and you just start investigating everything in your house. Things to keep in mind, of course, is that if, like our lemon juice, it's already got a little bit of a color to it, or there's, solid matter kind of floating in it, that will influence what you see. But give it a try anyway and see what happens. Just note the before and the after. So more things I'm going to try is I have hand sanitizer. I have some all-purpose cleaner, lime juice, key lime juice even, and then I have some club soda. So I'm going to try the hand sanitizer first because it's definitely become, a staple of our lives. I'm just gonna put it right in there and see what happens. So I'm just swirling it around and seeing. It looks a little like it's getting a little pink. It is basically colorless, but if we look at the ingredients, it's got a lot of alcohol, but alcohol is soluble in water. They mix well. But it's got some other stuff in there too that we can look at the inactive ingredient list. But it looks very similar. It looks very much like the tea solution. And so let me show you. Here's one that hasn't been exposed. I think that's just the rose tea. So if we look, it just looks a little bit cloudier, but not that pink color, and definitely not the yellow, right? Okay, so the next one I'll try is an all-purpose cleaner. I'm going to observe it when I pour it into the cap and see. It looks colorless to me and clear, so no solids floating around. I do know that it's got, lots of ingredients here on the back, but I'm going to dump it in and see what's going on with this cleaner. So I'm putting it here. Hey, now that is green, which means it's in a more basic environment. The anthrocyan is now in a more basic environment. And so to me, it definitely looks green. Okay. So it might be hard for you to tell. This one is the rose tea with nothing in it. This one's the one with the cleaner. And to me, which is why you're going to have to try it along at home, is that it's definitely got a greenish tint to it now, which you can definitely see when they're next to each other with that nice white background. Okay, so that's kind of fun. Okay, so I know now that this is more basic, more alkaline than the anthrocyan's normal environment is. Okay, so that's fun. Okay. Now let's try the key lime juice, and this one's got a fun top to it, I believe, which I can just drop it right in. So I do know, let's take a look though, because again, it's not colorless. In fact, it's cloudy like typical fruit juices are, because it actually squeezes out maybe some pulp, stuff like that. So I want to keep that in mind because I might get a very similar result that I got with the lemon juice. So I'm just going to add a few drops in here. Aha! Look at that pink! Ooh! It's even more pink than I saw with our lemon juice. I will show you. Look at that. Look at that. So that one is just the rose tea by itself. And look at that beautiful, almost a peach color. It looks to my eye to be maybe a bit peach on this side. That's the one that's got the lime juice in it. So lime juice, acid, but you probably knew that already. So this last one, okay, is club soda. It's just anything you have in the kitchen. Let's give it a whirl. Of course, if you're under the age of 18 or with roommates, please ask. if you can actually do all these tests before you, and if you need adult supervision. So here's some club soda. It's colorless, it's clear, and then I don't see any solids floating around. So I'm just gonna add this in. Hey, it did something. I think. No, not really. Didn't really do a whole lot. I think it's just, it's not anywhere like the pink, right? Real dramatic pink. This has got that greenish tint. This is just cloudy, not that much. No, not really. Just to compare. So if I were to look at just my stopper full of rose extract, the hot water extract, it's the same. I got too excited too early. It's not doing a whole lot. So that's kind of cool. We got a real different response, right? And that means that we know something now, not only about the rose, but the rose allowed us to know a bit more about each of the things we tested. You know, not a whole lot going on with the hand sanitizer, very similar chemical environment, didn't cause a big swing with the anthrocyan. However, right, we did see with the all-purpose cleaner, it's a bit green. I call it a bit green, so it's a bit more alkaline. That's interesting. Real pink with the lime juice, which was a fun color change to see. And not a whole lot going on with the club soda, but I gotta say, wasn't super expecting it. But now we know. And that's why we always like to investigate and explore. So I hope that you'll see how easy this was and that you can do like I did and just start exploring around your own kitchen. Maybe even your bathroom. What's going on with your shampoo and conditioner? All right, everyone, go out and explore.